So hello everyone, we are going to start with sheet metal today. For that we are going to see some theory before starting the sheet metal in SolidWorks. So I have some theory here. We'll go through this theory so as to understand what commands we are going to see and what reference points we are going to need it there for executing the commands. So to start with sheet metal, here is some introduction about sheet metal. What is sheet metal? Sheet metal is one of the shapes and forms in metal that can be bought in. Sheet metal is any metal that is in the form of sheets and has thickness range of 0.15 to 6 millimeters. So what does it means that sheet metal thickness ranges from 0.15 mm to 6 millimeters. We can go above 6 millimeters also for the sheet metal thickness, but then it may be considered in weldments, or else the metal property should be ductile enough so as to provide bend in sheet metals. Then we can go above 6 millimeters for the thickness range. Sheet metal manufacturing is the process of creating sheet metal parts by cutting, bending and forming. So these are the basic operations which are used to form the sheet metal parts, that is cutting, bending and forming. Sheet metal is a thin, flat form of metal. It is shaped by rolling methods such as hot rolling and cold rolling. So there are different methods to provide sheet metal parts. One of the two major methods are hot rolling and cold rolling by using different kinds of cold rolling or hot rolling equipments. Now you can see one image is showing here hot rolling process. In the kinds of parts we are going to manufacture in sheet metal. This kind of parts can be manufactured by using sheet metal. So you can see CPU cabinet here, one box, grid boxes, drawers, brackets, and multiple parts that can be made in sheet metal. So there are different types of sheet metal operations which are used, such as shearing, punching, perforating, notching, sheet metal cutting, blanking and fine blanking, piercing, slotting, bending. So most of the sheet metal work is dependent on this operation, that is bending. So we will see what is bending. So what is sheet metal bending? Sheet metal bending refers to the process of shaping the metal sheets. Manufacturers bend the sheets to make them easier to use in various products. So basically we are going to bend the sheets at different angles and obtain the different kinds of shapes and sizes of the product. Lastly, the final product will be made. So bending is must to understand. Now here difference of hot rolling and cold rolling process is given. So before learning sheet metal in SolidWorks, you need to understand what is hot rolling and cold rolling process also. So just go through the difference between the hot rolling and cold rolling operations. It is available anywhere on the net. Then here it is shown bending terminology. One piece of sheet metal piece is bended here. You can see. So this straight portion it is shown as flange length, and this straight portion which was earlier then bended was shown as setback. Here this neutral axis portion in between which is bended, it is known as bending allowance. This width of the sheet metal piece is known as bending length. Here the inner side of the angle it is known as bending angle, and the inner side of radius is known as bending radius. Outer side is not known as bending radius. We have to refer bending radius as inner side radius. So always keep in mind that we are going to refer inner side radius as a bending radius. Here it is given a thickness. This is the neutral axis which changes its position after bending. So this is the basic terminology of sheet after bending. So there are some terms which we are going to require, such as K factor, bending allowance, development length. Sometimes K factor, bending allowance, development length formulas and problems are also asked. So you should be prepared for understanding what is K factor, what is bending allowance, and what is development length. So here we will see K factor. The K factor in a sheet metal working is the ratio of neutral axis to the material thickness. Now what it means that K factor you can see here, small t by capital T. So this small t is nothing but neutral axis offset. You can see here, this is the neutral axis, and the distance from the inner side of the sheet metal piece to the neutral axis is known as neutral axis offset. So this is referred as small t, and the total thickness, that is sheet thickness, is referred as capital T. So the ratio of small t by capital T is nothing but K factor. Further you can read here, when metal is bent, the top section is going to undergo compression. You can see here, this top section is going to go under compression here, and the bottom section will be stretched. So this bottom section is stretched here. the line where the transition from compression to stretching occurs is called as neutral axis. So the line where the effect of compression and expansion does not occur or does not have any effect, that is known as neutral axis. So this location of neutral axis will not be same as in middle. It is going to differ depending on physical properties of metal or material and the thickness of the material. So in short we can say the K factor is the ratio of neutral axis, that is small t, and the material thickness, that is capital T. So the K factor is given here, and one chart is showing here different kinds of K factor referred according to the material and properties. So here you can see if the radius is equal to thickness, then aluminum will have the K factor as 0.33. If it is steel, then it is going to have K factor as 0.38. If it is hard steel, then it is going to have K factor as 0.4. And suppose if radius is going to be 3 times the thickness, then aluminum will have the K factor as 0.4. Mild steel or medium steel will have 0.43. Hard steel, the K factor is going to be 0.45. If the radius is going to be above 3 times the thickness, then the aluminum, mild steel and stainless steel, all three materials will have the K factor as 0.5. So all the things are dependent on material properties for K factor as well as the metal thickness. So why the K factor is very important here? It is because we are going to find development length, and in development length calculation bending allowance is required there. So to find out bending allowance, you can see here K factor is must. So this is the formula to find out bending allowance, that is bending allowance BA equals to capital A pi by 180 in bracket R plus KT. So all the initials, the meanings are given here. BA stands for bending allowance, A is for bending angle, R is inside radius, K factor, then material thickness. So K factor plays very important role to find out bending allowance as well as development length of the part. Bending allowance formula is given. You should understand this formula and then go for calculating the development length. The development length formula is given here. LT stands for flattened length equals to A, that is straight flange length, plus B, that is straight flange length of the other side, plus bending allowance. So this part was having two straight flange lengths as well as one bending allowance. So we just have to add all these things, A plus B plus this bending allowance, and you will get the development length. So this was the theory we required to understand before starting the sheet metal work. Now we will go for SolidWorks and go for sheet metal commands. So to start with sheet metal, the first command we are going to see here is base flange. For base flange, you can either make open sketch or you can go for the close profile also. Both are applicable here. So we'll start with base flange command. You can see here. Select the command, required plane, and go for the sketch. I'll make one zigzag cross section here, one joke plate. Provide the dimensions required. I'll say it 50 mm. This one has 25 mm and the other one has 35 mm. Now after putting the values required, we don't need to put up the fillets here as it will take bending radius. So directly we will exit the sketch, say sheet metal and base flange. So in base flange, first option is direction 1. We have to provide the extrude distance here. I'll take it as 50 mm. Provide the reference from mid plane. If you want to reverse the direction of the thickness, you can see the thickness is coming at the outside of the sketch. You can reverse the direction. Then go for the thickness option. I'll put up the value here as 1.5 mm. And I'll keep the same value for bending radius also here, that is 1.5 mm only. K factor as 0.5. So the values we have taken here are extrusion for 50 mm, thickness of 1.5 mm, bending radius of 1.5 mm. Bending radius should always be equal to thickness or more than thickness. It should not be below the thickness, or else the part may be weakened from the bending area there. So that's why bending radius is always taken as equal to thickness or more than thickness. I'll say it okay here. Now this part is completed using base flange. Parameters we have provided were K factor, bending radius, thickness and direction of thickness. Now we will start with new file here. Select the sketch. We are going to make one panel in sheet metal. For that I'll make one base flange using midpoint line here. I am taking midpoint line as because I want all the reference plane to come at center. That's why we are starting the part with center line only or midpoint line only. Say horizontal. I'll take this distance as 300 mm as I want the panel box width to be 300 mm. As I want this panel box width to be 300 mm. Next, sheet metal base flange. Put up the extrusion value here. I'll say it 150 mm. I'll take it from mid plane and then say OK. Thickness here I have taken 1.5 and bending radius also as 1.5. K factor as 0.5 only at this time. Say it OK. If I want to reverse the direction of thickness, again I'll go for base flange. Say edit feature and reverse the thickness. Now you can see the reverse thickness. I'll say it OK again. The next command we are going to see here is edge flange. Select the required edge flange command, and as the name suggests, it will start from the edge side. I'll select one of the edge and put up the height here. Click on the screen and then go for the flange length. So I'll put up the length here as 80 mm. Then we have to show whether this 80 mm is coming from bottom side including thickness, or we have to exclude the thickness. Both the options are given here. Outer virtual sharp means including the thickness and inner virtual sharp means excluding the thickness. So I can go for either options here. I'll go for the base option only. Next, I'll go for flange position. So there are multiple options given here for the flange position. If I go for the first option, that is material inside, all things will come inside the edge reference. If I say thickness excluded or material outside, then thickness will come outside of the sketch or selected edge. If I go for the total material bend outside, select the bend outside option, all the bending will come outside the edge reference. So these are the three options given here. First one is material inside, second is material outside excluding thickness, and third one is given as bend outside. Complete bend will come outside the edge. I'll keep material inside. Usually it is referred as material inside only. Then this trim side bends, we'll see it later. Then the other command here, it is given as offset. If I want offset, I'll go for offset. The flange position will take offset distance from the edge. We can provide here the distance required, say 5 mm. So instead of coming from the edge, now the flange is coming by taking offset distance of 5 mm from the edge and then going for the height required. So it is one of the flange position only. First we have seen all these three positions, then we have seen this offset option. Suppose if I put off the option, again it will refer from the edge only. Next, if I want to change the angle, above options are given here as angle. So I'll take this angle as 135. Now it is taking bending from 135 degrees. If I want this length 80 mm to be tangent from this radius, I'll go for the third option here for the flange length, that is tangent bend. Now this 80 mm is coming from the tangency, imaginary tangency line and this particular edge. So in between distance it is coming as 80 mm. I'll again put up the value for the angle as 90 degrees. Next, if I want to edit the radius of the bending, then I can put off this option and go for the editing option for the bend radius. You can also edit the edge flange profile from here. Select the edge flange profile. And then you just need to drag from the bottom sides and provide the distance whatever you require from the sides. I'll put up this distance at 50 mm here from this side and 50 mm from the other side also. Now this flange is coming at center of the edge. Just finish the option, it will be updated there. Now we can see here gap is coming. It is called as auto relief. This gap is compulsory is to be given. It is because when you bend the flange from the middle portion of the edge, multiple stresses will be developed here and the area of this metal will have shrinkage here. So to avoid the shrinkage from this area as well as to relieve the stresses from this bending here, we have to provide this gap, that is called as auto relief. So this auto relief you can see here on both sides. For that we have to give the values here. So go in edit flange and at the last you can see custom relief type. So here in custom relief type, I have taken the option here as rectangular shape relief type. So that's why it is showing a rectangular shape here. If I want to change the type, I'll say round. So it will take a round portion here. Again I'll go for rectangle. And this width and depth is totally dependent on the ratio given here, that is 0.5. So what the ratio value here it means is, suppose if I am having a thickness that is 1.5 mm. So if ratio is taken 0.5, then it will take the gap or depth in value as half of the thickness. That's why it is taken 0.5 ratio. It means half the thickness, that is 0.75. You can click and see here, this value is coming 0.75. Also the width, it is coming here as 0.75. And this one is horizontal one is width and the vertical one is depth. Suppose I want multiple flanges together, I'll again go for the flanges option, select the required flange, and you can click on the other edges also to make the edge flanges. All the four side edge flanges are completed here with flange length of 80 mm and angle as 90 degrees. Here you can see the gap as 0.5 mm. It is shown here 0.5. Now if you want to change the gap, you can go for the gap option and say 1 mm. Then this gap is updated for each corner, that is 1 mm. Say it OK. Now you can see 4 edge flanges are given here. Suppose if I go and delete one of the flange, now you can see only 3 edges are showing here. One edge I have deleted here. It is because I want to take this edge of different height here. That's why I have deleted the edge. I'll say it OK and again say edge flange for the second time. You can see I'll go for this edge and put up this height as 130 mm. Say it OK. And now I'll go for the flange positions. You can see blind 130 mm position is taken from the bottom face, including the thickness to the end of the height, and the flange position here it is taken as outside the bend. I'll say it material inside and then OK. So after saying material inside, if you go for this condition at this time, after changing the height, these bends will overlap each other. So to avoid this overlapping, I'll again go for edit flange and here I will say trim side bends and then OK. Now this overlapping side bend is been trimmed here. For that only that trim side bends option is given so as to avoid the overlapping of the bends. Now you can see these 3 flanges are of different height and the other second option we have taken here is of another height. So this was edge flange option given. Now in edge flange, again I'll go for editing this flange, and we can also edit in the way that if I want to delete this relation, say OK, and if I want to add one more sketch here, I'll take corner rectangle here, select the corner rectangle and trim the side bends and then finish. So this way also you can edit the flanges here. You can see I have given one more gap and added one more profile here. Now we will continue with other commands in next lecture. Till then, thank you.